Today class we're looking at finding the ability to find the sum of measures of exterior angles of a polygon. We'll start off with a little investigation. This problem should look pretty familiar to a problem we did yesterday. What it says is algebraically find the measures of angles K and L. We'll start off by just saying that these two angles should be able to be X. So we'll be able to start off by just writing a little equation here. We'll say X plus 68 plus 105 plus 109 has to equal, well, the sum of the interior angles of a pentagon are going to be 540 degrees. We'll say that's 2x plus 282, if we combine like terms, should equal 540. If we subtract 282 from both sides, we'll just have 2x equals, I think that's 258. And if we divide both sides by 2, x equals 129. What that tells us is that angle K is 129 degrees, as well as angle L is 129 degrees. Secondly, it says extend each of the sides of your pentagon. So what that looks like is I'm just going to extend this side this way. So this is kind of going to be a straight line like so. This is going to extend down this way, so it'll be a straight line like so. This one will extend further this way. This one will extend further this way. And this one will extend further this way. It's kind of tough to do in a really nice way. But really what we're doing is we're kind of making a pinwheel out of this whole thing. Each of your extensions is going to go in the same direction. We'll make these are all kind of going clockwise, I guess, as we go around. What that enables us to do is use the linear pair conjecture. Remember, a linear pair means that there's two angles that are right next to each other that form a line. So this is a line right here, line JK, just kind of extending in this direction. The idea with it is that you'll have two angles, one angle and two angles, that sum together to be 180 degrees. It says use the linear pair conjecture to calculate the measure of each exterior angle. Okay, so if this is 68 degrees, I know that 68 plus 112 degrees has to equal 180. 105 plus 75 has to equal 180. So really what I'm doing is a straight line. That means these two angles need to add up to 180 degrees. So what is the other measure that I need to have? This would be 109 and 71 degrees would add up to 180. If this is 129 up here, this would be 51 degrees out here. And this would also be 51 degrees out here. Okay, so we found that each of the measures there. The last thing, step 4, says calculate the sum. Remember, sum means plus. Calculate the sum of the measures of the exterior angles. So we're just going to add up these angles that we just found. So that'd be 112 plus 75 plus 71 plus 51 plus 51. When we add these up, if my calculations are correct, we should get 360 degrees. Okay, this isn't a coincidence. This is a number that does come up a lot in mathematics. It isn't a coincidence. It's just a number that does work out nicely for us. To sum this together, for any polygon, the sum of the measures of a set of exterior angles is going to be 360 degrees. If we were to pick any other polynomial, we could have done the exact same exercise and we would have gotten 360 degrees. This is kind of what we're focusing on, is the sum of the exterior angles. Again, sum and exterior angles is going to be 360 degrees. What that enables us to do, if we look at example 1, is to find the value of x in our diagram. It lets us calculate one of the missing angles for us. So we don't have to worry about how many sides or angles this thing has. All we do is we simply add up each of the exterior angles, and they should sum together to be 360 every single time. It doesn't matter whether it's a pentagon, a square, a rectangle, or a 17gon, they should always add up to 360 degrees. So if I combine like terms here, I would have x plus 332 equals 360. If I subtract 332 from both sides, I would then get x equals 28. That tells me is that 28 is the measure of this exterior angle right here. So 28, 65, 63, 92, 112, all those will add up to be 360 degrees. Why don't you try example 2 on your own? Just pause this recording, take a minute, try it on your own, and we'll compare results in a minute. Okay, welcome back. Hopefully what you did is you set up an equation. That'd be x plus 89 plus 2x plus 85. What's different about this problem is that there's two variables on the outside. They're both x's, so we can still add them together. We can still combine like terms. So that should be 3x plus, if we add together 89 and 85, we should get 174 equaling 360. If I subtract 174 from both sides, I simply have 3x equaling 186. When I divide by 3, 18 divided by 3 is 6, and 6 divided by 3 is 2, so x should equal 62. That tells me this measure right here is 62 degrees. This measure is going to be 2 times that, so that'd be 124 degrees. Notice what I'm looking for is I'm looking for the sum of the exterior angles. Okay. On this next slide, you don't necessarily have this, but if you can find some extra room on your paper, some diagram like this I think would be really, really helpful to look at. If we're talking about the sum, and we're talking about interior angles. This is a little bit of review, any of our interior angles that we've talked about. There was a formula that we used. It was n minus 2, this was in parentheses, times 180 degrees. That gave us the sum of the interior angles. Yesterday we talked about how instead of summing we could find each interior angle. Well, this also dealt with, like regular polygons. So each interior angle of regular polygons, this was n minus 2. This was in parentheses. And then we divided this by n. Today what we're doing instead is we're looking at exterior angles. So we're looking at exterior angles. And we just found out the sum of all the exterior angles is always 360 degrees. So this is kind of a nice way that if we're looking for sum, if you see a key term of sum, you see interior angles, you're going to use this formula. If you see sum and you see exterior angles, you know it's going to equal this. So we just add them together and it should equal this. If it says each or an or every interior angle is regular, we're going to use this formula. What if it says each exterior angle of a regular pentagon? Okay, well, we'll have to take 360, and just like we divided by n up here, we'll also divide by the number of sides and the number of angles. So it's also another formula if we're trying to find each exterior angle of a regular polygon. So let's check this out. Example 3, it says find the measure of each exterior angle of a regular. So those are some of the key terms. Each exterior angle, regular, and this is a dodecagon. If you remember dodecagon, the do means 2, the deca means 10, so 2 plus 10 is 12, so we have a 12-sided polygon. All we really need to do in order to solve this is take 360 divided by n, or in our case 360 degrees divided by 12. That would tell us that each angle on the outside of a dodecagon, on the exterior of a dodecagon, is going to be 30 degrees. Let's try one more of these really fast. How many sides does a regular polygon have if each exterior angle is 24 degrees? It's kind of the backwards approach to the problem that we just did. We know that 360 degrees divided by n, divided by the number of sides, is going to equal this 24 degrees. So what we need to do is we need to solve for n. So we'll have to multiply always by the denominator in order to solve for your variable. So we have 360 equals 24n. In order to solve for n, then we divide both sides by 24. So n is going to equal 360 divided by 24, or n simply equals 15. So if we have the exterior angle of a polygon is 24 degrees, we know which polygon are we dealing with. We're dealing with a 15-gon. Okay. Just in review, I'd say it'd be a really important thing to be able to reproduce this diagram. To be able to realize this, I think this would be a really good cheat sheet for you, that if you're looking for the sum of interior angles, you're going to do this. If you're going to do each interior of a regular polygon, you're going to use this formula. Each exterior angle of a regular polygon, you're going to use this formula, or the sum of the exterior angles, you're going to use this. Okay, this is all I have for you today. Make sure that you ask any questions if you ever have them.